Welcome to the Neural Intel Deep Dive. We're here to, really unpack the technical side of AI and machine learning research. And today we've got a really fascinating challenge on the table, how AI is learning to understand not just what's in an image, but what it actually implies, the deeper meaning.
Exactly. We're diving into a specific framework called LAD, that's LAD, for Let Androids Dream. And our goal today is purely technical, exploring how this system is engineered, how it tries to bridge that gap between just seeing pixels and, well, grasping the kind of nuanced understanding humans have.
Right. And we're using the research paper, Let Androids Dream of Electric Sheep, as our guide here. The title itself kind of gives it away, doesn't it?
It does. It points right at the problem. Think about that Philip K. Dick question.
Yeah.
It's about deeper consciousness, deeper meaning. AI models, especially these big multimodal ones, MLMs, they're great at basic visual question answering VQA. You ask, what's in the picture? A, they can tell you.
They miss the subtext,
Yeah,
the implication.
precisely. They struggle with what the paper calls these contextual gaps, understanding metaphors, cultural references, the feeling of an image. That's where current AI often falls short.
Okay, so it's like seeing the pieces but not the puzzle picture.
You got it, like seeing smoke and fire, but maybe not grasping the full implication of danger or emergency without extra help.
And LAD is presented as a novel approach to tackle this specific technical challenge. What's the core engineering philosophy behind it?
Well, what's really interesting is that LAD is explicitly inspired by human cognition, or at least a model of it. It uses a three-stage process: perception, search, and reasoning. The idea is to mimic, in a structured way, how we might look at an image, think about it, maybe look things up, and then draw a conclusion.
Okay, 3 stages. Let's break that down. Starting with stage 1, perception. What's the technical objective there?
The main goal in perception is to take that raw visual input, the image, and turn it into useful textual information. Rich, multi-level text. The paper mentions an analogy to human system 1 and 2 thinking.
Ah, the fast intuition versus slow analysis idea.
Exactly. System 1 is that immediate, intuitive, take the vibe of the image. System 2 is more deliberate, focusing on specifics. LED tries to capture both.
So how does it technically do that? What are the steps?
First, it uses an MLLM, a multimodal large language model, to generate a pretty detailed text description of the image. This is like the initial sweep. What text is visible, what are the main colors, the layout, key objects, kind of a surface-level report.
Right, laying the groundwork. What happens next?
Then it gets more focused. The MLLM takes that detailed description and distills it down. It aims for about 7 key keywords. And these aren't just random nouns. They're chosen to capture things like the image's emotion, its potential domain. Is it political, cultural, humorous? Maybe rhetorical devices like symbolism.
Oh, interesting. So if there's a white dove, a keyword might be symbolism and the domain piece.
Precisely. It also includes important text or objects from the first description. So this stage gives you both a broad narrative and these focused keywords. It converts the visual into actionable text.
Okay, that sounds like a solid foundation. Stage 1 gives us this processed textual representation. What about stage 2, search? How does LAD go beyond that initial perception?
Right, so stage 2, search, is all about tackling ambiguities and deepening that context. It knows perception alone might not be enough. It uses an iterative process to retrieve knowledge, basically plugging those contextual gaps we talked about.
Hmm.
And a key technical aspect here is its adaptive search. It's smart about where it looks for answers.
Adaptive search, how is that structured? You mentioned phases.
Yeah, it's broken down into plan, search, and summary. In the plan phase, it uses those keywords from stage 1 to generate 5 different levels of search questions.
5 levels. Why so many?
The idea is to probe different angles, maybe uncovering hidden meanings, checking cultural references, finding background info that isn't obvious just from the imaging keywords.
Okay, systematic exploration. Then comes the search phase itself. How does it answer these 5 questions? This sounds complex.
It is, and it's quite clever technically. There's a self-judge mechanism. The MLLM basically rates its own confidence for each question. It asks itself, is this something that needs really current niche info? Or is it general knowledge I probably already have?
Ah, so it decides whether to look things up online or just use its internal knowledge.
Exactly. High confidence score means it probably needs fresh or specific data, so it triggers web search. Lower score, it thinks its internal knowledge is enough, so it uses model search.
Smart optimization. Avoids hitting the web for everything.
Right. Model search just leverages the MLLM's built-in knowledge base. Quick, efficient for common stuff.
And web search, how does that work when it does need outside info?
Web search is more involved. It doesn't just dump the question into a search engine. First, a planner module breaks the main question down into smaller sub-questions. These are structured, organized as a DAG, a directed acyclic graph. Think of it like creating a research plan.
Okay, breaking down the problem.
Then a searcher component takes over. It retrieves information online for each sub-question, grabbing relevant snippets and facts. It's designed to be hierarchical and handle complex queries better than a simple search.
And it pulls all that back together.
Yes, it synthesizes the findings from the sub-questions to answer the original bigger question posed in the plan phase. It's a multi-agent approach, quite sophisticated.
Oh, okay. So that's the search. What about the final phase, summary?
Summary is about cleaning up and focusing the results. You've got answers to those 5 questions, potentially a mix of internal and web results. First is rank summary. The MLLM looks at all 5 question-answer pairs and ranks them based on how relevant they seem for understanding the image's core implication. It picks the top 3.
Filtering for relevance.
Then refine summary. The MLLM takes those top 3 pairs and rewrites them, consolidates them, removes redundancy, maybe resolves conflicts, adds details if needed. The goal is to produce one concise, optimized summary of the most relevant external and internal knowledge found.
Okay, so stage 2 actively digs for context, filters it, refines it. That refined summary then feeds into the final stage, right? Stage 3, reasoning.
Exactly. Reasoning is where LAD pulls it all together. It takes the initial perception, outputs the description, the key words, and combines them with that rich contextual summary from the search stage. The goal here is explicit reasoning. It needs to derive a contextually grounded interpretation of the image's implication. And crucially, it aims to make its thinking process transparent.
How does it achieve that transparency? What's the technique?
It uses a specific format, prompted with special tokens like think and think. Inside these tags, the MLLM basically lays out its step-by-step thought process. It shows how it connects the visual cues, the keywords, the search knowledge, how it arrives at the final interpretation. The paper calls this a domain-specific chain of thought, or Kate method.
So it's not just giving an answer, it's showing its work, which technically is really valuable for understanding how it got there.
Absolutely. It makes the whole inference process much clearer and helps ensure the final understanding is actually aligned with the evidence gathered.
Okay, that covers the 3 stages. Now, evaluation is key. How did the researchers test LAD? What benchmarks did they use?
They used established benchmarks like TIE-Bench and CII-Bench. These are multiple choice question formats for image implication, covering both English and Chinese, but they also created their own, which seems particularly relevant, the Open Style Question Benchmark, or OSQ.
Open style question. What's different about that one technically?
It uses the same images as the multiple choice tests, but instead of choosing an answer, the AI has to generate its own explanation. The prompt is simply, what is the implication in this image? Much harder.
And how do you evaluate that kind of open-ended answer consistently?
That's a challenge. They developed a detailed scoring metric looking at 5 aspects: surface-level info, emotion, domain context, rhetorical skills, and the actual deep implications. And interestingly, they found very high agreement, like 95.7% consistency between human judges using this metric and scores given by GPT-4 using the same metric.
Wow, that's a strong validation for their evaluation method itself. High human AI scoring agreement is pretty significant technically.
It really is. It suggests the automated scoring is capturing something meaningful about the quality of the generated implications.
So with these benchmarks, what were the performance results for LAD?
Well, the results in Table 1 of the paper look pretty compelling. Using GPT-4 Mini, a more efficient version of GPT-4o LAD actually achieved state-of-the-art results on both the English and Chinese benchmarks.
State-of-the-art even with a smaller base model.
Yeah, on the multiple choice questions, its performance was comparable to the full GPT-4 and even GPT-4.1, which are much larger models.
That points to the framework itself doing a lot of heavy lifting. How did it do on the harder open-style questions?
That's where it really shone, actually. On the OSQ benchmark, LAD significantly beat GPT-4o. We're talking a 36.7% improvement for English OSQ.
A 36% jump? That's substantial.
It is. And compared to just using the base GPT-4 mini model without the LAD framework, the improvement was massive, like a 68.2% relative gain on the English or multiple choice questions. It clearly shows the framework adds enormous value.
Very impressive numbers. Did the paper offer any technical insights comparing different types of models on these tasks?
Yes, they noted something interesting. Models specifically designed for reasoning tasks didn't show much extra advantage here compared to general VQA models. It suggests that understanding image implication might require a different blend of capabilities than, say, pure logical deduction problems. It's a distinct challenge.
That makes sense. And they did ablation studies too, right? To isolate the contribution of each stage.
They did. Table 2 looked at LED code, which is basically stage 1, perception, and stage 3, reasoning, without the search stage in the middle. Even without the search, LED code performed significantly better than standard chain of thought methods. It shows the perception and reasoning stages themselves are effective.
Okay, so perception and reasoning add value on their own. What about adding stage 2, the search component?
That's in Table 3, looking at LED search. The results were clear. Adding stage 2 consistently boosted performance across the board on both multiple choice and open-style questions. An LED-specific search method outperformed other techniques they compared it against, like Grok Search or Perplexity.ai, especially on those tricky open-style questions.
So the ablation studies really confirm that all 3 stages work together, each contributing significantly. Did the discussion section offer any other key technical takeaways?
It really reinforced a few core ideas. First, how LED tries to emulate human perception by creating those rich text representations going beyond just objects to capture tone, domain, rhetoric. Second, the importance of that explicit, structured chain of thought in stage 3 for linking the visual evidence with the knowledge found during the search.
Making the connection clear.
Exactly. And third, how crucial stage 2, the search, is for overcoming the limitations of static knowledge in MLLMs. Getting that external, up-to-date, or niche information is often vital for understanding metaphors or ambiguities.
It paints a picture of a very deliberately engineered system. Now, no research is perfect. What technical limitations did the authors acknowledge?
They mentioned latency as one potential issue. That search stage, especially web search with multiple model calls, can add time to the process. They also flagged the potential for bias in the OSQ evaluation. Even with that high human-AI agreement, relying on GPT-4o for scoring could introduce some model-specific biases. It's something to be aware of.
Fair points. And what about future technical directions? Where do they see this work going?
Primarily, they want to optimize that search strategy, make it faster, more efficient, maybe reduce the number of model calls needed without losing performance, and also continue refining the OSQ evaluation metric to make it even more robust.
Okay, so summing up this deep dive on the LAD framework,
Yeah.
what are the main technical points for our listeners to take away?
I think the core takeaway is that LAD represents a really significant technical step in getting AI to understand image implications, not just image content. It does this by integrating these 3 stages: a human-inspired perception, an adaptive knowledge search, and explicit, transparent reasoning. It's the synergy between them that's key.
And the performance, particularly on those difficult open-style questions, really highlights its potential, showing substantial gains over even large base models. It points towards more context-aware visual reasoning in AI.
Precisely. It really underscores the complexity of the technical challenge building AI that gets visual nuance. But frameworks like LAD show we're making real progress, pushing the technical boundaries of multimodal AI.
Absolutely. It leaves you thinking about what's needed to bridge that gap fully. For those of you who want to dig even deeper into the technical specifics, the paper, Let Androids Dream of Electric Sheep, is up on Archive.
And the code and project details are also available on GitHub, which is great for transparency and further research.
Definitely worth checking out if this area interests you. Thanks for joining us for this technical deep dive. We'll catch you on the next Neural Intel.